Okay, we have to cover this locus in complex numbers. Okay. Before we go into the locus in complex numbers, you people need to recall what you have done in locus in your O-level mathematics. Okay. How many of you remember that what is the locus of a point from another point? Can you describe the locus of a point from a given point at a particular distance? Yeah, it was a straight line. Yes, Mariam? It was not a straight line, yeah. It had to be something related to a circle. Like if you are, for example, look at this. For instance, there is, you see, here is a point, let's say there is a point O over here, and here is a point A, which is always 5 centimeters from this, the point O. So this is the locus of A, okay? So you can describe it as that the locus of A is the circumference of a circle with the center O and the radius 5. Okay. So whenever you have to say something about a circle, so you have to mention the center of that circle and the radius of that circle. Okay. Now, something related to this we have in our complex numbers. Now, um, imagine we have a complex number which is, let's say, there is a complex number u which is 3 plus 4 iota. So when you draw this, when you mark this on the Argand diagram, so you have its exact location. This is 1, 2, 3, 1, 2, 3, 4. So here is a point A which is representing this complex number 3 plus 4 iota. Okay. What is this length OA? Oh, sorry. Yeah, that is 5, which is the modulus of this complex number. You can even tell what is this angle over here. So that will be like, I think that is 53.1 degrees. And that is the argument of this complex number, which is 3 plus 4 iota. Now, imagine you are just given that there is a complex number z whose modulus is 5. So show the locus of the complex number whose modulus is 5. So we just have the modulus, but we do not have the argument. So what would you say? So this would be a circle then. Now look at this. Suppose you have, like you see, it might be over here because its length from this origin is 5. Okay. That complex number might be over here because you see again, this length is 5 from the origin. This can be over here as well. Okay. This can also be over here. Like there are many, many possibilities. It can be 3, 4. It can be 3 minus 4, 4, 3. Like whatever, whichever complex number we have with the modulus 5, that can be representing this situation given to us, that is modulus z, that is equal to 5. So I'm just going to use this diagram here. So we would say that the complex number with us is, so this is the, now this is the locus of z. This is the locus of z. Okay. Now go back to your coordinate geometry where you learned how to write the equation of a circle. Now suppose there is this now we cannot be sure of the coordinates of the point on this circle. So if I say that in general there is a point which is x comma y over here, in this case keeping this as x plus iota y, can you give me the equation of this circle? Yes. Do you remember equation of a circle? Shaleen, what would be the equation of this circle then? X plus whole square equal to 5 square. Very good, beta. So basically the equation of a circle is x minus a whole square plus y minus b whole square, that is equal to r square. And in this case, we have x minus 0 whole square plus y minus 0 whole square, that is equal to 5 square. Okay. Now, please let me say that this modulus of z is actually representing x minus 0 whole square plus y minus 0 whole square, and that is going to be 5 square. Okay. Now, अब जरा होश से, ठीक है, you have to tell me, can I write this as x plus iota y minus 0 plus 0 iota modulus that is equal to 5? If you just simplify this, if you have x plus iota y minus 0 plus 0 iota, if you simplify this, can I say this is x minus 0 plus iota into y minus 0? Yes? Batao bhai. And what will be its modulus? That will be this square plus this square. There had to be a square root on it, but that square root is cancelled because of the 5 square. Okay, so you have to note it down that whenever you have modulus of z, that is equal to a. The modulus of z, that is equal to a. So that would mean that the locus of the complex number z is on the circumference of a circle with the radius a and the center as origin. Center as origin. Okay. Now I'll be building on it the next thing. Now, suppose instead of this, you have something like suppose you have z minus 2 plus 3 iota modulus that is equal to 2. If you're keeping this thing in your mind over here, this thing, this thing, this thing, can you tell me what is, how to describe this thing? What is the locus of that z if z minus 2 plus 3 iota modulus that is equal to 2? Now remember one thing, this modulus is actually, this always refers to the distance, the modulus, okay? Now this would mean that the distance of the complex number z from this number, that is equal to 2. Okay, suppose you're representing this with the point A. So can I say this is going to be a circle whose center would be this 2 plus 3 iota and the radius will be 2. Okay, if you allow me, I can show you a bit more explained. Instead of z, I'll be writing x plus iota y, and this is 2 plus 3 iota. Okay, and then I say this is going to be x minus 2 plus iota into y minus 3. Okay, and that is equal to 2, that is equal to 2. Then I find the modulus. Okay, so that is going to be x minus 2 whole square plus y minus 3 whole square, that is equal to 2. And then I take the square on both the sides, that is x minus 2 whole square plus y minus 3 whole square, that is equal to 2 square. Now isn't it the equation of a circle with the center 2, 3 and the radius 2? Yes. So from this, please remember that whenever you see something like this, so that would mean, like whenever you see this modulus and you're being asked about the locus, so modulus should immediately bring a circle in your mind. Okay, when circle comes in your mind, then there should be two questions coming in your mind following that thing, that what is the center of this circle and what is the radius. If it just say modulus of z, so what will be the center? Origin. The center will be origin. And if it says something like z minus x plus iota y modulus, that is equal to, let's say, a over here. So this would mean the circle's center is x plus iota y and the radius is a. Okay? Now you have to maintain a minus over here. How many of you remember when you were studying the vectors and there you had AB that is equal to OB minus OA? Do you remember this? Now AB is the position vector of B relative to A. So that is B from A, OB minus OA. So this Z minus X plus iota Y means Z from this X plus iota Y. Okay, so this means that this has to be the center of the circle and this is going to be the radius. Now when you think about drawing the circles, so many of you people start assuming that you might have to bring or take those compasses with you in the examination hall. You will not be required to do that, because now let me tell you why don't we need the circle, I mean the geometrical box there. You need a ruler because you will have to draw the lines. Do draw the lines through the ruler and then you can have a scale through those markings on that ruler. Okay. Now suppose the question is, that the z minus 2 plus 3 iota, that is equal to 2. Now you draw this circle and then I'll tell you, you try this. So no compass is required here. Examiner would like to see that if, let me change the color so that people can see at the back. Look at this, okay. Now the center of the circle is going to be 2 plus 3 iota, 1, 2, and this is 3. Okay, now but please see. Examiner would like to see that you have to draw these lines to the ruler, okay? Now this is the center. Let me call this point A over here. This is 2 over here and this is 3 over here. Now you people are required to show that this circle has a tangent which is this imaginary axis because its radius is 2, okay? So this should be passing through this point 0, 3. This should be passing through the point 2, 5. This should be passing through the point 4, 3. And this should be passing through the point 2, 1. So you have to show it like this, okay? So this has to be going like this. So I'm believing that we have 1 over here, okay? And this is your 4, and this is your 2, 5. So this has to be seen. Now, suppose the very next question was that what is the maximum argument of z? If z is such that blah, 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 then what is the maximum modulus of z? Can you tell? That is pi by 2. Because if z happens to be here, its argument is greatest. Got it, bacho? Okay? Khair, I'll be giving you the questions related to this locus. Beta, this circle means that your complex z number can be anywhere on this circumference. So if it can be anywhere on the circumference, then what is its maximum possible argument? That is, if the maximum argument is when it is at this point. This point. Yes, that is 90 degrees. How can you determine the minimum argument? I'll have to draw a tangent here as well, like this. Okay. And this will be giving me this is the minimum argument. And you see that all of your O-level trigonometry will be used. So look at this, you will draw a triangle like this. Now these questions are just in the way, okay? So let's proceed. Now suppose the question was z minus 2 plus 3 iota modulus is less than or equal to 2. So what would that mean? That would mean that the complex number is inside this circle. It is anywhere inside this circle. Okay. If it was given as greater than or equal to 2, so it can be anywhere outside the circle. You will be shading according to the situation. Okay, so you just remember that this is going to be anywhere outside the circle. Now don't start shading the whole universe except that circle. Okay, what if there is no equal mark over here? Yeah, you will keep the circle dotted. You have done this in your O levels. Okay, so that means the circumference is not included in this. Okay, so please remember this, the circle thing. Whenever you have this thing, blah, 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 so that means it is about circle. You see the modulus, foreign circles in mein aana chahiye, okay? And when you have circle in your mind, then two things should be following that where is the center of that circle and what is the radius of that circle, okay? Now related to this, I have one more thing over here. Let me see who will tell us that how to show this locus. Now, suppose you have z minus 2 plus 3 iota modulus that is equal to z minus, let's say this is 4 minus iota. What would this mean to you? Then you're very close. You're very close. Actually, you're giving the exact correct answer. No. Okay. Anyone else? You people are talking exactly like 100% correctly, but you're not reaching that conclusion. Yeah. So yes, इससे आगे एक लाइन है. बिल्कुल पहुंचे हुए हो. What do you call that? अभी इसने ईशा ने सारा बता दिया है. और थोड़ा सा लाइन बाइसेक्टर की बजाय perpendicular bisector. Okay, now you see that you people have reached to this yourself. You concluded it yourself. Now you see. Now suppose beta, this 2 plus 3 iota, let's represent this in blue color. Okay, now this is the point A, okay, and this is the point B. Charlene, what does this mean? Z minus. Why don't you come closer? There are so many seats available here. Okay. Charlene, what does this mean? What does all of this mean? Z's position from A is same as Z's position from B. So this, in your O-level terms, this means Z is equidistant from A and B. Z is equidistant from A and B. So whenever you see that there is Z minus X plus iota Y, I should change the color because people can see this. That is equal to z minus a plus iota b. So that means the locus of z, is the perpendicular bisector of the points representing this complex number and this complex number. Or in other words, the complex number z is equidistant from both of these 2 points. Let me call them A and B. So z is equidistant from A and B. Okay? Got it, bacha? So I have to proceed now. Abhi